New thumb drive, new projector, I love it. Okay, 4:30, Landon's birthday. So our objective today is really going to be special right triangles on the unit circle, okay? And I need to grab my unit circle, and I need to add some things to it, okay? All right, so first of all, what I want to do today is put a 45, 45, 90 triangle into the unit circle, okay? Now I just want you to watch. Don't draw anything, but I want you to watch. So technically, and I'm going to use a pencil because I'm going to erase this. I want you to watch. Technically, I could put a 45, 45, 90 triangle into the unit circle, correct? If that's the case, and this gigantic circle is on a grid, then you could have a coordinate right there. Capiche? Now the coordinate is going to be decimals, right? Because, you know, it's less than 1 on both cases, correct? Does that make sense? This point right here, if that's 1 and that's 1, that coordinate at 45 degrees would be less 1. But we need this coordinate. So how do we get it? Well, we're going to go back and take a look at this triangle here. So we know if this is 1, and we look at our special right triangle, right? Then it turns out that this, if 1 is equal to your x squared to 2, right? Then my x value would be 1 over the square root of 2. So this side is going to be 1 over the square root of 2. But I don't like that answer because, Nina, we're going to rationalize it, right? We don't like answers with square roots in the bottom, so we rationalize. So we multiply it by square root of 2 over square root of 2. Remember how I did that before? We get a better answer of the square root of 2 over 2. Now that's what I want for this value. God bless you. So what I did is I knew that the 1 was the hypotenuse. It relates up there to that triangle as some x squared to 2. If I need the value of x, I solve for x. I go 1 divided by the square root of 2. I'm going to, and that is correct, but I don't like that answer, so I rationalize it. So this is also square root of 2 over 2 because it's a square, right? So then if I go to my triangle, my 45, 45, 90 triangle, I'm going to have a coordinate here. And the coordinate of this point is going to be, well, let's see, it's going to be square root of 2 over 2 is the x value. Square root of 2 over 2 is the y value. So on this triangle, which of course is super little, I'd go over square root of 2 over 2, up square root of 2 over 2. So the coordinate here is the square root of 2 over 2, comma, square root of 2 over 2. Okay? So this is my 45, 45, 90 triangle. It is this triangle right here on the unit circle, okay? So the x value is square root of 2 over 2, the y value is square root of 2 over 2, okay? Now,
Put that in.
yes, put that in. And you don't need to draw the triangle because it's just going to be a mess, okay? So put that in, yes. So then on the other side, well, I'd have another 45, 45, 90 triangle right here. Again, don't draw this. Just let me draw it because I'm going to erase it. I'd have an identical 45, 45, 90 triangle here. However, the difference is you have to go back because it's on the coordinate grid. So I got to go back and then up. So the coordinate would be a negative square root of 2 over 2 because you go back and then up a square root of 2 over 2, okay? And then you'd have another 45, 45, 90 triangle on the unit circle, right? And it would be down here, right? You could draw that in. Here's my other 45, 45, 90 triangle. But it would be, to get to this coordinate, you'd have to go back and then down. But it's the exact same triangle as what we have over here. But the difference is you have a coordinate of a negative square root of 2 over 2 and down, which is another negative square root of 2 over 2. Okay? Hopefully this is making sense. Okay, the unit circle really is full of triangles. So then, all right, there would be another 45, 45, 90 triangle sitting right here. Okay, do you see another 45, 45, 90 triangle right here? It has a coordinate, same exact triangles above, except you'd have to go over and then down. So the x coordinate would be positive square root of 2 over 2. but the y value would be down, which is a negative square root of 2 over 2. Okay, so give me thumbs up if that made sense. That makes sense? Okay, good. We're getting somewhere because it's not that difficult, I don't think. It would be difficult if you had to figure it out on your own, correct? Kind of know what I'm doing. Okay, then let's look at our other special right triangle. Okay, so you've got this one here. And if we look up on the board, it's like the special right triangle here. This one is the hypotenuse, which is twice as long as this side. So this side has to be 1/2. Right? Hypotenuse is twice as long as the short leg, and then the longest leg is going to be this number times the square root of 3. Okay? I'm going to rewrite this as just the square root of 3 over 2. All right? 1/2 times square root of 3 is the square root of 3 over 2. And these are the two numbers I'm going to put into my unit circle. Okay, so then go to my unit circle, and right here is a 30-degree angle. So right here is a 30, 60, 90 right triangle. Okay, so then I'm going to take these values and I'm going to put these values into this triangle. So my length, my x value is the square root of 3 over 2. My y value is 1/2. So the coordinate right here is going to be a square root of 3 over 2, 1/2. Okay? And again, this triangle is really on the coordinate grid. This 30-degree angle is right here. So you'd have it right there, but it's really small. So we blow it up, and this would be the actual coordinate right there on the circle. Okay? Now we'd have another one of those over here, correct? We'd have another 30, 60, 90 triangle, the identical triangle that's over here. So its coordinate, though, is back. So the same length. So it'd be a negative square root of 3 over 2, and then up 1/2. Okay? How am I doing? Is it making sense? Okay, and then I'd have another 30, 60, 90 triangle, but it would be here, right? I'd have another 30, 60, 90 triangle. Here's my right triangle there. And it would be the same size. I'd go back square root of 3 over 2 and down 1/2. So the coordinate would be a back negative square root of 3 over 2 and down 1/2. So on the unit circle, if I put it on graph paper, it'd be right about there, and then that's the actual coordinate on the graph. Okay, so then finally I've got one more 30, 60, 90 triangle, which is right here, right? And it's going to have the exact same size as the one up here, except for it goes over square root of 3 over 2, but then down 1/2. So its coordinate would have to be a square root of 3 over 2 and then negative 1/2. Okay, how am I doing? Okay, good, doing good. Okay, now let's look at our other 30, 60, 90 triangle, where it's standing up at the 60-degree angle. Okay, so this is my 60-degree angle, but it's still a 30, 60, 90 triangle. We know that if the hypotenuse is 1, it's twice as long as the short side, so the short side is 1/2. And we know the long side is going to be whatever this is times the square root of 3. So it's 1/2 times the square root of 3, but I would prefer to call it the square root of 3 over 2, okay? So again, we're going to put these two values on our unit circle. We're going to put this triangle into my unit circle, okay? So let's take a look at it. Am I going too fast? I'm okay? All right, so this triangle is sitting right here in the unit circle. You guys see it? I've got my 60-degree angle, so it's a 30, 60, 90. I need these coordinates, so it's going to be x value of 1/2, y value of square root of 3 over 2. So the coordinate right here is going to be a 1/2 square root of 3 over 2. And then I have another one of those here. I've got another 60, 30, 90 triangle right there. Same exact triangle, except for we go back 1/2 and up the square root of 3 over 2. Okay, so we'd have a coordinate here of back 1/2 and then up the square root of 3 over 2. Okay, how am I doing? And then down here we have another one of these 60, 30, 90 triangles. It's right down here, right? You guys see that? And then the coordinate is going to be at a back 1/2, and then down the square root of 3 over 2. And then finally, I'd have one more 60, 30, 90 right triangle right in here. And then it would have a length of 1/2 and then down the square root of 3 over 2. So its coordinate would be over 1/2, positive 1/2, but then down, which would be a negative square root of 3 over 2, okay? Now, we've created our unit circle. We can do trigonometry on our unit circle without a calculator, okay? So let's take a look at what we have, okay? So our notes. We know that the sine value is the y over the r. We learned that yesterday. And we know the cosine is the x value of the r, and the tangent is the x over y, right? So let's be more specific. On the unit circle, since, again, the radius is 1, from the unit circle, then sine is just the y value. From the circle, on the unit circle only, because the unit circle radius is 1. Same thing with cosine. Since the radius is 1, the cosine value is just the x value. Tangent's still going to be the y over the x, okay? So let's take a look at this, sine of 30 degrees. Okay, I'm going to go to 30 degrees. All right. And I go to 30 degrees, and sine is the y value, right? So I go to 30 degrees, what's the y value? 1/2, right? So my answer, sine of 30, is 1/2. Now, okay, well, if I want to just cheat and use my calculator, well, hold on, wait a minute, just a second. If I go sine of 30, boom, I am smarter than a calculator. Look at that, all right? Cosine, 315 degrees, so I go to my 315 degrees, my unit circle, 315, cosine's the x value. Cosine's the x value, there's my answer. 135 degrees, cosine's the x value. So I'm going to take the x value out of my point, which is negative square root of 2 over 2. Now here's the bad news that you're not going to like. If you are going to try and cheat and use your calculator, and you go cosine of 135, I'm going to mark that wrong.
It's 315.
Oh. Oh. Same answer though, isn't it? No, it's positive. I'm dyslexic this morning. Look at that. I was totally dyslexic. Thank you, Dallin. Thank you. I am dyslexic this morning. So let me do that. Cosine of 315. Boom. 0.707. I will not accept that answer because it's a decimal equivalent to square root of 2 over 2. Everybody understand that? I want the exact answer. Tangent of 180. Okay, so I use my circle. Tangent is the y value over my x value, so I go to 180. I'm going to go my y value, which is 0, over negative 1, which is 0. Okay. Sine of negative 30 degrees. Okay, well, sine of negative 30 degrees. If this is 30 degrees rotation, then negative 30 degrees is here. Does that make sense? That's 30 degrees, then this is a negative 30 degree angle. I'm going to put that on my circle because it's going to help me out. And I'm looking for, in this case, the sine value, which is my y value, so it's a negative 1/2. Cosine of 400. Oh, this should probably be 420. Again, my bad. It should be, I got to fix that. Cosine of 420. Yeah. Yeah. Change that to 420. I don't know what was wrong with me. It's track season. Okay, so 420 is the same thing as 360 plus 60. Okay? 420. So what I really want to find is cosine of 60. Because 360 and 60 more is 400, okay? 400 degrees is here. All right, does that make sense? So then, I want the cosine, which is the x value. I want my x value. And my x value of cosine is 1/2. Cosine of 60 is 1/2, okay? I'm so smart. Tangent of 90, which is the y value over the x value, right? Tangent of 90, I go to the y value of the x value is 1 over 0. Uh-oh, Cookie Monster's gonna be pretty sad. Right? Cookie Monster's sad, you can't divide by 0, so this is undefined, okay? How am I doing? So let's turn the page. So now let's do it in terms of radians, okay? So now if we do it in terms of radians, it's easy. We could try it on our calculator, but we have it on the unit circle. Sine is the x value, the y value, and 3 pi force is here. The y value is square root of 2 over 2. So I go to the point, x, y value is square root of 3 over 2, square root of 2 over 2, and that's the sine of 3 pi force. Cosine 5 pi 6 is the x value. All right. 5 pi 6 is here. I'm looking for the x value. There it is. There's my x value of my point. Every point's x, y. There's my answer, negative square root of 3 over 2. Okay, give me thumbs up. Am I making sense on this? Does this seem easy? Because I don't want to insult anybody, but I always think, I'm hoping this is an easy day if I explain it well, okay? Okay, tangent's going to be the y value over the x value. So 2 pi thirds. Okay, 2 pi thirds here. So it's going to be the y value over the x value. So square root of 3 over 2 divided by negative 1/2. So it's going to be square root of 3, negative square root of 3 over 2 over 1/2. Now that's not a very nice looking answer. But I know from 6th grade math, if I divide fractions, I'm going to do a little work up here. 6th grade math, negative square root of 3 over 2. I can invert and multiply, right? Remember 6th grade math, a fraction divided by a fraction, so I invert and multiply. And then we're so smart we know so the 2 should cancel, right? You guys see that? And then what we wind up with is just negative square root of 3. And that is the tangent of 2 pi thirds. All right, sine of negative pi halves. Okay, well, pi halves is here. Pi halves is here. But that's a rotation. Let's rotate negative pi halves, which puts us here. We need the sine value, which is the y value, which is negative 1. So I need the y value. The y value is negative 1. Cosine is the x value, right? But 3 pi is going to take a journey. 1 pi, 2 pi, 3 pi. I need the x value, which is negative 1. 3 pi halves for tangent. Now again, tangent is going to be the y value over the x value. 3 pi halves is here in my unit circle. I'm going to go the y value over the x value. Uh-oh, I'm going to have, Cookie Monster's going to be sad. Can't do that. Undefined, right? Okay. Undefined. Can't. Oh, did I put this wrong? Yeah, I did. Gosh darn me. It's Friday. Now, example 4. Sine is the y value, right? In radians, I need a pi answer. So where on my unit circle is the y value 1? Right here. My y value is 1 right here. What's my angle? Pi halves. be, let's divide by 2 first. Okay, divide by 2, cosine of theta is equal to negative 1/2. I need an x value of negative 1/2. Well, it's right there. There's my x value of negative 1/2, which is 2 pi thirds. You guys see that? So my theta is 2 pi thirds. Oh, wait, there's a second answer because it's the unit circle. Guess what? It's also there. See negative 1/2? So there's 2 answers. You can also take 4 pi thirds. So theta can also equal 4 pi thirds. Okay? Now, tangent of negative 1. Okay, tangent is going to be the x over the y. It is right there. Tell me why that's negative 1. Why is that value negative 1? Tangents, y over x. This divided by this is what? This divided by this is what? This divided by this is negative 1, isn't it? So we'd have it 3 pi 4. So theta is going to be 3 pi 4. Where else does that happen? One other spot, and that's right here. Negative square root of 2 over 2. It's dividing by itself. It's also at 7 pi 4. Okay. Now I'm running low on time, so I'm just going to do C, okay? Because that's unit circle. So this is not on the unit circle. How do you find this answer? Well, all you got to do is change your mode to radians. I'll show you how that works. So if it says calculator, you got to be careful in your mode. Okay? You got to change your mode to radians, and then just do cosine of 1.3, and you get an answer about 0.267. Okay, that's a big day, right? Lots of stuff.